Let's look at demand functions and their dependence on price. We say that good 1 is ordinary if the demand for good 1 is decreasing in P1. Similarly, good 2 is ordinary if x2 is decreasing in P2. Here is a picture. We start with some given prices and level of income, resulting in the following budget line. Here is the optimal indifference curve in this situation, and here is the optimal bundle. If we increase the price of good 1, the budget line will become steeper with no change in the intercept like this. Here is my new optimal indifference curve and my new optimal bundle. Increasing P1 even further, we have the following budget line, indifference curve, and optimal bundle. As you can see, the demand for good 1 has decreased and good 1 is ordinary. The demand for good 2 has decreased as well in this example, but since this is not due to an increase in P2, we cannot say if good 2 is ordinary or not. If the demand for good 1 is strictly increasing in P1, then we say that good 1 is a Giffen good. Remember that the preference relation in a two goods model compares bundles with certain quantities of each good. This means that whether an individual weakly prefers one bundle to another can only depend on these quantities and nothing else like prices and income. It is conceivable though that preferences are affected by prices in what is sometimes called a snob effect. A good may become more desirable simply because it is expensive. If it is the case that demand for good 1 increases with price due to such a snob effect, then the good is called a Veblen good. For a good to be a Giffen good, the demand for the good must be an increasing function in its price even when prices has no effect on preferences. Giffen goods are probably very rare. One example that is often mentioned is potatoes during the Irish Great Famine in the mid-19th century. The argument goes something like this. Due to a potato disease and a reduction in the supply of potatoes, the price of potatoes increased. Since a large proportion of the Irish population spent a significant proportion of their income on potatoes, this left them so poor that they had no other choice than to demand more potatoes, as it was still cheaper than, say, pork. Whether this story is true or not is hard to say. Several papers have been published claiming that it is not. In any case, it remains a theoretical possibility as the following picture illustrates. Here is my initial budget line, indifference curve, and the optimal bundle. The price of good 1 increases, resulting in this new budget line. It's not easy to draw, but here is the optimal indifference curve. If you were to continue to draw this indifference curve upwards, it would go to the left of the previous one. As you can see, the demand for good 1 has increased despite an increase in its price. You can also see that there is a large decrease in the demand of good 2. Increasing the price of good 1 even more, with the new budget line and the new indifference curve, demonstrates an even larger demand for good 1. If the price of good 1 keeps increasing, then eventually the demand for good 1 must fall. Indifference curves giving rise to a Giffen good are really weird looking, and it's actually not easy to find a utility function representing such preferences, although it is possible. We defined the income offer curve as the collection of all optimal bundles as we varied income. We can do a similar analysis by varying one of the prices. What we then get is the price offer curve. So the price offer curve is simply the collection of all optimal bundles as we vary one price, keeping income and the other price fixed. Here is a picture. Let's begin with the high price for good 1. Budget line, indifference curve, and optimal bundle. Decrease the price of good 1 and the budget line will rotate outwards. Here is a better indifference curve and a new optimal bundle. Let's do one more. Budget line, indifference curve, optimal bundle. Now imagine doing this continuously for various values of P1. Connect all of the optimal bundles and we end up with a price offer curve for P1. Here is a mathematical example of a price offer curve. Starting from a Cobb-Douglas utility function, u equal to x1, x2 with m equal to 10 and p2 equal to 1. The optimal choice is x1 equal to 1/2 m over p1, which is 5 over P1. x2 is equal to 1/2 m over P2, which is 5 independent of P1. As we go from a high value of P1 to a low value of P1, rotating the budget line outwards, x1 will increase while x2 will remain constant. Therefore, with Cobb-Douglas preferences, the price offer curve for good 1 will become the horizontal line intersecting the x2 axis at x2 equal to 5. Plotting the optimal demand of a good against price will give us the demand curve for the good. For historical reasons, the price of the good is drawn along the y-axis while the demand is drawn along the x-axis. This is really kind of weird. Since demand is a function of price, it would make more sense to draw demand on the y-axis. Therefore, the demand curve is the graph of the inverse of the demand function, p as a function of x. The inverse will always exist if preferences are well behaved. We have considered the demand function of a good and its dependence on income and the price of the good. We can also look at how the demand of a good depends on the price of the other good. For example, how x1 depends on P2. If it is the case that x1 increases with P2, then we say that good 1 is a substitute for good 2. If it is the case that x1 decreases with P2, then we say that good 1 is a complement to good 2. Let's understand why these definitions make sense. Remember that the two goods are substitutes if they are viewed as very similar to the consumer. A cheeseburger and a hamburger are viewed as substitutes by many consumers. If the price of the cheeseburger, P2, increases while the price of the hamburger remains the same, consumers will then tend to demand more hamburgers and x1 increases with P2. On the other hand, complements are goods that are consumed in pairs, such as sushi and wasabi. If the price of sushi increases, the demand for sushi as well as for wasabi will fall. x1, the demand for wasabi, is a decreasing function in P2, the price of sushi.